All right, good morning. My name is Steve Valoria. I'm the president and CEO of a company called MediaPoint, and we manufacture streaming media technology specifically for the enterprise. So what we're here to talk about today is basically fundamentals and applications of streaming media, but really in the enterprise space. So we want to talk about the basics that you need to know in order to implement streaming media within an organization. What we're going to talk about is delivery systems and methodology. We're going to touch on the types of distribution systems there are on the market and focus a little bit on signal makeup, formats, and protocols. So often people really don't understand what type of format they should be encoding in, how much bandwidth they need, so we're going to focus on that a bit. The types of technology and how you implement them. And then we're going to talk about a hot topic in the industry today, workflow and content management. And we'll look a little bit into the future as far as where the technology is going as well. So first of all, why did we begin converting analog media to data originally? Anybody? Initially, interestingly enough, the reason that we started doing it was to compensate for losses in analog media and also for the dynamic limitations of recording media. You remember when the CD first came out, digital audio, and it was considered that digital's better than analog. But if you think about it, really everything that you see and hear is analog. So even when you're looking at the screen, you're receiving it, your eyes as analog, you're hearing analog, we produce analog. So basically it really can't get any better than that. But because of the limitations of the technology, people started to think when digital media first arrived that this was better. Digital meant better quality. Today, we convert analog media primarily for the portability of the content, the ability to move media anywhere, anytime, to be able to have it accessible anywhere in the world. And the irony here is that we've almost flipped it over on its head because now we sacrifice quality for portability. More often than not, we'll accept artifacts in recordings, low bit rates so that we have something that streams very efficiently on a web page. And it's kind of the opposite of where we started. So let's look at streaming technology. First, you're converting video to data and basically turning it into packets that can be sent over a network. And obviously, we call that encoding. Transmitting that data is really what streaming is. And you could, depending on whether you're just streaming an event live or whether or not you're saving it for video on demand playback later, you could archive it as well and store it as a file. And then when you decode that data, those digital packets, you're converting that data back into analog video. So common day example of that, you've got your digital TV provider, and you've got your decoder, which in this case is basically your television tuner on your digital cable network. Or maybe you went for the DVR, so you're actually archiving that content as well as decoding it. And when you actually decode the content and bring it onto your television screen, of course, you've turned it back into an analog signal to view. A lot of people confuse that because they say, well, wait a minute, it's a digital signal, it's a digital TV. Again, as the image is viewed by you, you're viewing light in analog. So again, we're talking about the enterprise streaming space. And really, the path of the data conversion is the same, a little bit different because in practical applications in an enterprise, in an organization, we're recording live events like this one. So then your sources might be computer graphics, camera, microphones, and you would record it on a digital media recorder. This is an example of one of the digital media recorders that we manufacture. When you decode that content, you're playing it back either on a dedicated decoder, like a set-top box within a dedicated network, or you're pulling it down either on that network or off the cloud on personal electronics, laptops, iPads. So let's talk about delivery systems a little bit. So there are several kinds of networks that are applicable to streaming. First and foremost are dedicated networks. Now, what's a dedicated network? A dedicated network can literally be nothing more than a switch and a couple of cables. Back in the analog audiovisual days, if you needed to move a high-resolution computer graphic signal from one end of a building to the other, you need a certain amount of amplification, a certain amount of frequency adjustment in order to maintain that signal. And you still do today if you're moving that as an analog signal. But it's actually gone to the point where the streaming technology has come down enough in price that we can effectively utilize it on a dedicated network for simply the purpose of moving a video signal from point A to point B. So that's one example of dedicated network. Your digital cable provider is another example of a dedicated network dedicated to the delivery of that content. IPTV networks are an example of dedicated networks that are not used for other purposes other than the delivery of content. And finally, there are networks that companies will set up specifically kind of below their normal local area network for delivering content. Now, area networks, we're familiar with LANs and WANs, which are essentially the same thing. They're private networks, and they're often used within an organization for moving the content actually on the same network that they're doing all of their data traffic on. The nice thing there is that you have design control, which becomes important in order to maintain the quality of those video signals on the network. And then finally, you have the internet, which of course, allows us a lot of portability of content, but there are certainly limitations, and we'll look at how you get around them. Okay, so the methods of delivery. First of all, live streaming. In live streaming, you don't have the ability, obviously, to pause and fast forward, go back, because you're basically just looking at a live stream. Whereas with progressive downloading, you're essentially catching up behind it, which allows you to play it. You've all probably seen where you have the line on your player, and you can see where the media is coming in ahead of you, and then you've got a little dot you can drag on it. And then video on demand, of course, is being able to receive content that's already been recorded and download it or play it back directly off of a server, depending on your network bandwidth. Now, client media players are used primarily as the way of playing back content. And client media players, when we describe those, we're pretty much talking about what you have on your laptop. It could be VLC or Windows Media, QuickTime, variety of different client players. At the same time, there are dedicated, like set-top box and decoders, that are hardware-based that can play content over a network. Streaming servers are, a lot of streaming devices basically have streaming servers in them, but streaming servers are dedicated in networks in order to host the bandwidth, and particularly the bandwidth necessary for the amount of users that might be hitting it over the internet. So it will be placed on a network somewhere where you're going to have a large enough pipe to handle all of the user traffic and also handle the variety of software servers for the different formats that people might need. And you may have multiple resolutions in the same format as well. So when you look at all of those needs, even though a streaming device in and of itself is a streaming server, we'll put a dedicated server on a network to really handle the user traffic. Load balancing is something that is necessary for large deployments. If you think about, if you're broadcasting, let's say we're broadcasting this event, and let's say people were really interested enough to be scattered all over the country tuning into it. You don't want everything to hit the pipe at the head end at the same time. So load balancing is a methodology for spreading that around in some logical sense. It may be because you're using public providers. It may be that your load balancing schema is what's the least expensive hops to go through in order to deliver that content. It may be what's the geo IP location of each viewer to take it the least hops to get to them. So there's a variety of different schema for load balancing, but again, that's how you get the distribution more efficient on the public IP as opposed to having everybody hit back to the source. And if you're really doing a large broadcast, content delivery networks come in. These are service providers that essentially receive a stream in a specific format, and they rebroadcast that stream essentially live. There's some delay, but the idea is they have these huge pipes on data, in data farms where they're able to transcode on the fly to multiple formats, multiple resolutions, whatever your viewing audience may need. And it's really something that's not practical unless you're doing it all the time to have for yourself. So content delivery networks are the primary service provider today for large-scale broadcasts via streaming. So let's talk about signal composition a little bit, because I can't tell you how often somebody says, with one of our products or a specific deployment, well, how much bandwidth do I need? I'm sure you guys have all heard this one before. It's a funny question, because if you understand the signal composition and how you affect that signal, you understand that most equipment today allows you to really vary the bandwidth requirement, and it's all about what you're doing with the signal. So let's talk about that a little bit. First of all, there's resolution, and here are some common display resolutions, common streaming resolutions that we work with. You can see the top three there are pretty much what are defined in the area of standard definition video. And you've got XGA, your typical standard for computer graphics at 1024x768, that's what we're looking at here. And then you've got 720p and 1080p, which of course are your high definition formats. Of course, you have aspect ratios to consider as well. 4:3, which used to be the standard for PCs as well as standard definition television, originally came from 35mm film format, and NTSC and PAL essentially copied that format in broadcast. It also then became the format that was copied by VGA signals, and that's why today VGA 640x480, what we used to know as our computer graphics VGA, is pretty much a standard for standard definition video streaming. 16:9, of course, our widescreen TV format, HDTV. If you look at these next to each other and you kind of compare, and these are relatively accurate as far as the differences in size and shape, you can see that the 4:3s across the standard computer graphics are fairly linear. You've got VGA up in the top left-hand corner, SVGA, XGA, SXGA, and UXGA, terms you're probably all familiar with, and people still say VGA to describe everything. Every one of these resolutions, people will still call VGA. And then you can see the 720p and 1080p 16:9 formats overlaid on that. So let's talk about frame rate a little bit for a minute. Again, as a manufacturer, we're often told the requirement for a given customer is we've got to have 30 frames a second. It just seems to be a common, for people who don't really understand, what you're doing and what compromises you're intentionally making when you're trying to stream something efficiently, that you've got to have the highest frame rate. You need 30 frames a second for video. When in reality, if you look at common usages, if you go and pay to go to the movies, you're looking at whether it's digital DVD created from something that was originally on film, or whether you're looking at film, that's 24 frames per second. We pay to see that, but we won't buy a streamer unless it's 30 frames a second. PAL is 25 frames a second. Half of the world is on that standard and doesn't find it 5 frames too slow. And NTSC truly isn't even 30 frames per second. We're splitting hairs there, but you see my point is that we really have a lot of usability and portability of content based on compromising some of the things that we've come to believe we need for high quality video. And the standard for YouTube is 15 frames per second. So before going on, let's just take a quick look and see what some of these look like. Can anybody tell me what frame rate we're looking at here?
Stupid.
15, correct.
She would never.
Otto, did you see anything suspicious? Anything at all? I won't make trouble for you.
Any guesses?
I just want the truth.
Nope.
God, I wish I knew the truth, I really do.
What did you say, 1? Oh, you did say 1, you're correct.
No.
Well,
On the list? No. But I believe my friends are. Perhaps you know them. Franklin, Grant, and Jackson.
Guesses what frame rate this is? Okay, that was 30 frames a second that we were just looking at there. Four?
The cops
Close. 5.
tried to shut the club.
And it's interesting when you look at some of these, video conferencing systems claim 30 frames a second, and people are typically, even on high definition systems, not seeing much more than 15. And it's just because it's adjusting for the algorithms as it compresses the video. So anyway, the often overlooked variable in the composition of a signal is color depth. And the reason these are important is because these are each variables that you as a user of video streaming technology have the ability to vary in order to determine how much bandwidth you end up needing. You know, again, back to that age-old question, well, how much bandwidth do I need for that streamer? Well, you know, what bit rate do you want? What color depth do you want? What resolution are you going to run? So it's important to understand these, and color depth is the one that is most often overlooked completely by people on streaming. We'll take a look quickly at some examples. Now, color depth is basically defined in how many bits per pixel per second in video. Now, here's a 1-bit image, and you can tell what the image is. There's really no color, no depth. It's a leaf, and you've probably got 3, maybe 4 different grayscales that are able to resolve on some level at that color depth. Now, let's go ahead and double that. And you can see you're still pretty much strictly in the grayscale range without resolving any colors. But suddenly you have shadowing, you can see depth perception and such. But keep in mind that if you go from 1-bit to 2-bit, you've basically doubled one of the parameters that affects your bit rate. If all you were adjusting is this, then you would have doubled the amount of bandwidth you're going to end up needing. Let's double it one more time to 4-bit, and now your color's coming out. You can see a lot of gradation, particularly in the background on the image. But again, we really see the color starting to come out at 4-bit. We'll double it one more time, 8-bit, and now you really see the image at 8-bit. Now, a lot of people who have problems with bandwidth and streaming video signals are essentially using too high, of a color depth for their application. Most of what we end up streaming in business, for instance, and in education, which are the primary users of enterprise streaming technology today, is PowerPoint. And if you're looking at big colors on graphs and those kinds of things, more often than not, you really don't need more than 8-bit. What we call true color is 24-bit, 24 bits per pixel per second. And we'll take a look at that now. And you'll see that even with a photograph, the differences are very subtle. But we've tripled the data that we're requiring to transmit per second on a given signal by going to 24-bit. You can see some gradation difference, particularly in the background on 8-bit, but again, going back and forth between the two, there's very little difference, and if you were dealing with pie charts and graphs and big bold colors in PowerPoint, it probably wouldn't even be discernible to you. So keep in mind these parameters when you're setting up your encoding, and that will help you to be efficient in your streaming. Okay, so all of these basically affect what we call your bit rate. That's the rate that you are transmitting. To have a feel for what bit rate's going to work in a given application, you really, you need to get a little experience with it. But here's a couple of just thumbnail guidelines for a 30 frame per second signal at various different resolutions. Now you notice that I've got ranges up here for what the actual bit rate of these signals will be. Does anybody know why there's ranges as opposed to just a specific number? Actually, while that could impact it, let's assume the question within a single given codec. It is the content, and I think you just hit on the key. Really, when we come back to what I was talking, the other elements of signal composition that I was talking about a minute ago, all of them affect it. If you suddenly have a much deeper color palette, it's going to require more data. But the number one thing that impacts it in video streaming is motion. The way that the algorithms and most compression algorithms work for streaming is basically they look at the entire image and they look at what's changing. Okay, so if I'm on an image right here, if you've got an image of me on camera and I move around, okay, so you'll see some pixels changing in this area, but the background that's on camera is static. And that's not changing. And the algorithms are smart enough to know that. So they're only going to reprocess the data necessary. And this is key in video conferencing, particularly because in video conferencing, most of the time, you've got fairly static images. I've had people come and say, well, why am I getting so many artifacts with a particular video that I'm streaming? And you'll go and look at it, and you'll see that they've got a camera that's slowly panning around all the time. No, we're moving it very slowly. That couldn't be affecting it. But if you think about it, if I'm static and you've got a wide shot of me, the only pixels that are moving are those when I move. If you pan it ever so slightly, even imperceptibly, every pixel in that image is changing as the camera pans. So those are the things that impact that range the most. Let's talk about transmission for a minute. There are various protocols having to do with packet transmission over a network. This is just kind of an overview of the different layers. You've got low-level protocols, which like IP, for instance, internet protocol is in fact a low level. And you've got high-level application protocols that determine how the packets are distributed and processed once they're received. You don't need to go into all this just from a basic standpoint, so let's just talk about the ones that you really do need to know about. UDP, or User Datagram Protocol, is basically sending a stream out there and not knowing from or not caring from what's happening to it. You're all more familiar with TCP, and what TCP is essentially doing is, in addition to your actual signal, there's an overhead on that signal which is creating a handshake between the host and the client. It's ensuring that the signal is being received properly, and it's even in some cases retransmitting signals that are having frame loss or having any kind of problems. So if you're dropping packets, for instance, TCP has the ability to go ahead and compensate for that, but it ensures and guarantees the delivery of content. With UDP, which is commonly used in Yoona Casting, and we'll talk a little bit more about that, you're essentially just, again, it's like a radio broadcast. You don't know who's listening. You don't know if anybody's listening. High-level protocols, just a few you need to know about. RTSP is the standard for MPEG-4. The reason that's important is because MPEG-4 is the predominant standard for streaming format today. We'll talk more about different formats, but it's important to know that it's not only that way today, but it seems to be pushing that way further with the proliferation of Apple, which of course is based on MPEG-4, the HTML5 standard, which is emerging, which is trying to standardize the industry again as it did originally with HTML1 and 2. These are all things that are driving the continuation, at least for the foreseeable future, of MPEG-4 being the reigning standard. Microsoft Media Server is very popular within organizations because of the fact that it supports both UDP and TCP. Makes it very versatile for people that need to do unicasting, multicasting, different applications. And HTTP, which you guys are all familiar with, is basically a TCP, strictly TCP-based protocol that solves a lot of problems in traversing firewalls and such, and therefore it's very popular for streaming media. And those are a few of them that you want to kind of keep in mind. So let's talk about the difference between unicasting and multicasting. Unicasting is basically based on UDP transmission, and you're sending data from one source to a destination. Each viewer that's going to view that content is going to get their own stream. So, if there's 30 of you in the room and each one of you is getting your own stream, that's 30 times whatever that stream bandwidth is in order to deliver it. It's less burden on networks that are not designed for streaming. And key here is it's routable across the internet. A lot of people think that they can do multicasting over the internet, and while we've done it before and it's possible, it really isn't a reliable and for the most part not feasible to do, because a network essentially needs to be designed in order to support multicasting. And that's one of the reasons that local area networks and wide area networks, within organizations are ideal for it. It is easier to set up. Obviously, you have to design a network to support multicasting. Sounds like a radio's picking up on the mic. And the number of users obviously is network limited. If you're sending a 1 meg signal and that 1 meg signal is going to 20 people, well, now you got 20 meg. It's going to 50 people, you have 50 meg. So it's obviously network limited as to how much bandwidth you have available. Here's an example of Yoona Casting. So we'll send a stream to the viewer here in the lower right. And we'll send another stream now to another viewer, and now a third stream, so 3 of the 4 on here. And you can see that as you get further and further upstream to the host, you have everything kind of bottlenecking back at before the first node, where all 3 streams have to go through that node. Now in multicasting, you're basically sending data from one source to many destinations, but really that's kind of not the best way to think about it. It's more like, again, think about it like a radio broadcast, where people are essentially tuning into the signal. Viewers are all sharing the same stream in multicasting, but again, it's something you can't do over the internet, and you have to design a network in order to support it. Much more efficient, though, because we'll serve up those same 3 users here, and you'll see, again, nobody's getting more than the 1 megabyte stream in any of the legs of distribution from the host down to the viewer. Okay, so you know about all the things, the individual parameters that make up the signal composition and how they affect bandwidth, but how do you calculate it? And it's funny because when I speak on this topic, a lot of times people don't think there is a way to calculate it, and it's actually very simple. If you're doing a unicast, then you basically take your bit rate, and in this case we'll use an example of a 1 meg signal. You multiply it times your number of users, so that would take it to 5 meg, and you add, to be safe, 20% overhead for TCP. Now, it's generally under 20%, so I'd say anything over 15% is safe, but 20% is really safe. And that would give you, for 5 users with a 1 meg signal, 6 megabit bandwidth requirement. If you're multicasting, of course, this is now a UDP signal, there's no overhead, and you're also not multiplying it for the users, so it's a 1-to-1 relationship. Now, the different formats on the market, there are a variety of them, obviously, and they come and go. And I'm a big believer personally in the fact that we really need to work with the standard format that's most prevalent on the market. That gives us portability and lifespan to our content. But let's look just at the common ones that are on the market today. MPEG-2 is kind of the broadcast standard. So both in HDTV, in DVD, video, these are based on MPEG-2. MPEG-4, which came along a while after that, is basically, it's the Apple standard, it's a QuickTime standard. It's much more efficient, and it has much lower bit rates as a result. Now, the most popular format for streaming in enterprise and organizations today is H.264, which is also MPEG-4. It's simply part 10 MPEG-4 as opposed to part 2. H.264 is the standard in video conferencing. Most of the streaming devices that you would see at a show like this are going to be based on H.264 streaming and encoding natively, and it's optimized for low bit rates, which is, of course, why it's the standard for video conferencing. Windows Media, of course, is there and still prevalent in a lot of applications, and really that's based on Microsoft operating system support. So it works well with Windows operating system, obviously, but at the same time, a Windows Media client, which is the player, the software player that you have in a Windows machine, is not limited to playing Windows formats. A lot of people think they are, and out of the box they are. That's the way Microsoft wants it. But you can install a MPEG-4 codec, for instance, as a software patch into your player on your laptop and receive, MPEG-4 QuickTime type video. Flash is one other of the very common ones that I like to mention because it's so highly supported. In fact, there was a time really where we felt that Flash was quickly, about a year or so ago, going to overtake MPEG-4 as the standard. It's the most widely used, the most portable, not widely used, but the most portable and most compatible and supported by virtually everybody except Apple. And Apple doesn't want to support it because they have the competing MPEG-4 standard. But with, you know, the explosion in everythings, which are all based on MPEG-4 and won't play Flash, and with the growth of the QuickTime standard, and also with the H.264 standard, which is such a popular and growing format, we really see, you know, we're not sure that Flash is going to really take over MPEG-4 like we thought to as kind of the king of the hill. And in fact, HTML5, you know, a new industry standardization push is all about MPEG-4. Now, of course, these formats, when we talk about them, it's important to understand that this is not, you're not talking about just a codec and just an encoding format. You're really talking about what we call a container. And that container has several things in it. They have a codec. Let's take Windows Media, for instance. The video codec inside of a Windows Media container is actually something we call VC1. You add that with Windows Media Audio. You add XML data, metadata, and that's what makes up that container that we call a Windows Media format or file. But it's not just the encoding format. It's actually the container that we refer to. Okay, so let's talk a little bit about standards. Why is it important to use the most prevalent standard on the market? Again, why do I feel strongly about that? It's because I think what a lot of the manufacturers of equipment and systems in this enterprise streaming media space are getting wrong is they're putting their system for encoding, they're putting their products and features above the most important thing, and that's the content. So if we think about the fact that the content is the most important thing here, and the technology should be transparent and is invisible to it, then why would we work with anything but the most prevalent standard? Because it's not only going to be the most portable, but it's going to have the longest lifetime. Give you an example. Let's say you are managing a university and you had the vice president come and speak 30 years ago in your auditorium. It was a big event. You have that recorded. You don't want to lose that content. 30 years ago, the prevailing video recording standard was VHS. If you had that recording on VHS, you still have that content today. You can do something with it. We know we don't have VCRs on us everywhere, but you'll be able to find, you know, a VCR somewhere. You'll be able to transfer it and code it to a digital file. The second most prevalent standard 30 years ago was beta. Now, if you got that on beta tape, you'd probably be out of luck. You wouldn't be able to find a Betamax player in order to play that content. So that shows you how important to the lifespan of content that you're creating standards are. And a lot of the players on the market are making these capturing and recording systems that basically create a proprietary file format. They'll say they're Windows Media based, or they'll tell you that they're MPEG based, but what they're really doing is they're combining JPEG captures of slides with multiple streams of video under a Windows format or a MPEG format, and then playing it back on an interface that they've designed. Without combining them in that interface, and combining them in that interface is in fact a format that they've created, you can't play that content. So it'd be pretty arrogant of those of us who are in the manufacturing end of the business to think that 30 years from now, we're going to be the reigning standard and you're all going to have your content protected because you recorded it with our proprietary systems. So that's why it's important. Just remember that content is the most important thing, and the lifespan of your content is key. And again, going with standardization, MPEG-4 is how you want to capture content for that reason. Now, if you're looking at adopting a system for capturing and streaming content, you have a lot of choices on the market. And there's something I like to call the feature functionality trap that you need to look out for. And again, I won't get into naming specific manufacturers. Well, okay, I'll name one that we acquired. A company called CompuServe that we acquired in 2005 was very much like a lot of the other players in the market, MediaSite, Panopto, Kumu, Encoded Media that are out there today. Same kind of thing. They're basically CompuServe was providing a standard definition video along with capturing PowerPoint slides and capturing them with JPEG captures, indexing those slides to the video, and then allowing you to play that back in their interface off the cloud or directly off a system, and jump around to different slides on the presentation and such. And that sounds like a great feature because you're able to index them and jump around and so on and so forth. A lot of the manufacturers are still providing these types of systems today. I call them slides plus video. And the problem is, we've already talked about the fact that this is essentially creating a proprietary format, and that doesn't mean just that the lifespan's threatened, but you can't really move that content around. I can't play it on my iPad, my iPhone. You really don't have the portability once you've done that. But what they pitch, and what you see, higher education, which is the #1 vertical utilizing enterprise streaming technology today, what you see is become a predominant standard because of that trend is these slides plus video systems that are essentially, kind of selling themselves based on editing capabilities, selling themselves based on indexing capabilities. If you just record a video and it's just a, one stream video playback, how are you going to index it? How are you going to edit it? And they have lots of, editing and indexing and closed captioning features and those kinds of things that they promote so that you will say, hey, that's superior capabilities, that's what we've got to have, and you're not thinking about the whole standardization and lifespan of your content. So to give you an example of an alternative to that kind of thing, I'm just going to show you quickly, it's not quite fitting on the screen here because I've changed my resolution for this projector, but we basically have one of my executive meetings, and I'll play a little bit of it for you. That's pretty loud. I guess I'll go ahead and pause that. I think the volume's a little high. But we can basically pull this up and index to any point. And let me just take the volume down here. We can go to any point in this thing we want. We can put keywords in there to go ahead and search to different spoken words and jump to that point in there, which is more powerful than any of those kind of feature-rich systems. And this is QuickTime. It's basically free, $30, I think, for the powerful version of it. So really, that not only has more capabilities in editing, in indexing, in closed captioning, and you know what? If you want to create a proprietary format, knock yourself out. You can add all the additional video streams and data streams and graphics you want in something like QuickTime. These proprietary systems on the market are not going to compete with what Apple's done in that product. It's the same with Windows Movie Maker. So don't be fooled by a manufacturer that offers you a proprietary format when you can do all of those things and do more powerful things on your own. And more importantly, because you're working with a standard, you're able, as I do, I'm able to look at and review all of the meetings that I have, that my other managers have on my iPad, on my iPhone, anywhere, anytime. Something you obviously can't do with a non-standard format. Now, a lot of people look at, well, what if I don't have content? In other words, I'm just recording a meeting. And if you record like we do in our office, we record all of our meetings, all of our weekly meetings for review. And the question is, do you really have content most of the time if you're not giving a presentation? A best practice is always to have content. And the reason is because while I can put chapter markers and indexes and jump around this thing in something like QuickTime, on a portable device that you're going to use, you don't have those capabilities. But if I go ahead and grab the bar to drag through this, not doing that very well, but as I drag it, you'll see it's moving through my agenda. So I can use that to index it simply because I've added content to the video. So we do that in all of our meetings. We go ahead and put our agendas on the screen, and in that way, every video file you've got has an automatic indexing sense in it because you can simply slide that cursor and move to anywhere on your agenda automatically. And that's great for portable devices. back to my presentation here. Okay, storage. Now, how do we calculate storage? How big a file will you end up with? Basically, you start with what bit rate are you recording at. But because storage is defined in bytes, you basically need to divide it by 8. There's 8 bits to a byte of storage. So you divide your bit rate by that, you multiply it times the duration of the recording, and then you have your size of the recording. In this example, again, a 1 megabit rate for 1 hour. We'll convert 1 hour to 3,600 seconds. We'll divide our bit rate by 8, giving us 125,000 bytes. And then we know that that file, 1 hour at 1 meg, will be 450 meg. You can turn that around for a variety of questions and answers. How long can I record for? Let's say you have a 450 megabyte storage device, but this time you're encoding at 4 meg. Then you want to go ahead and divide that by 8 to get your bytes, and divide it again by 60 seconds in order to convert to minutes, and you know that on a 450 megabyte storage device, at 4 megabits, which would typically be, you're talking like a 1080p signal, you would get 15 minutes of recording. Now, excuse me for 1 second because I'm not getting power and this thing's gonna die. Anyways, if we have an AV person here that might be able to look at this, I don't want to lose my presentation, but I'm not getting power to the laptop. Let's continue going through this. Because the content management is one of the biggest things we need to get our arms around today on the market. The proliferation of the use of streaming technology is what's really driving this. If you go back, say, a few years ago, people were starting to implement streaming, but they really weren't thinking about content management. But if you think about it, if you're a university, for instance, you're capturing all your lectures and you're starting to generate and amass a lot of content, it'd be kind of like all of your Excel worksheets named Book 1, Book 2, Book 3, all in one file folder, where you wouldn't know, what file was what. So content management systems basically take that content and they give you the ability to catalog, publish, and share the content. In order to do that, you need to do things like put metadata. It goes into an XML file header. When you look at something on YouTube and you're able to see, the specifics about that file, a paragraph about it, who the author, copyright, those kind of things, that's all done in a content management system. But they're also robust in the sense that they have all of the sharing and permissions and conditional publishing capabilities as well. Still not there. Now quickly, I want to touch on the types of equipment that you're dealing with. I think you got it. Thank you. And fortunately, we're not going to end short here. The types of equipment that you have really fit into 3 categories in deploying a streaming solution for your organization. First, there's encoders and decoders. And I'm talking about encoders and decoders that don't do anything else. They're not recording. They're not strictly set-top boxes. They're strictly turning an analog signal into a digital one and turning a digital signal into an analog one. The type of systems that we work with are blade-based, and they can be brick-based or blade-based. We use blades because you can put them in little boxes and they become bricks, or you can put them in a card frame. And this basically is the way you would build something like an IPTV network. You might look at that card frame and say, why would I want all of those blades? Typically that's going to be at the head end. Those are all going to be encoders. They might even be different signal types, or they might all be the same signal type. But this is the technology that's typically used to replace broadband distribution systems today. Is anybody familiar with broadband distribution systems? Okay, broadband distribution systems, more commonly known as CCTV systems, cable systems, they're basically dedicated RF distribution of video. Typically you'll have that on a corporate or an educational campus. And those are being replaced by network with encoders and decoders. So you might have, for instance, a rack with all those encoders at the head end, and you put, let's say, 4 different educational channels if you're a university that are right off air, C-SPAN and a few different channels. And then at the same time, you'll go ahead and put decoders on displays in classrooms so that you can tune, like you would a television, a channel. The difference is instead of actually tuning an RF frequency, like on a CCTV system, you're actually tuning, you're actually pointing to an IP address. But to the user, it's transparent. Next category is recorders and players. So a digital media recorder basically takes in multiple inputs of analog or digital information, encodes it into a digital file. It can typically combine different images like that QuickTime of executive meeting that I showed you. They can be controlled in a variety of ways, either from a control system, from a handheld remote, but most often they're controlled over a web portal. And then a player, like a dedicated set-top box, is essentially just a decoder. The difference between it and a decoder is that it has a user interface. So essentially, you'll typically have it sitting on top of a display, you'll have a handheld remote, and it will give you on-screen menus, for instance, which allow you to browse content. But other than that UI, it's essentially a decoder. And finally, the last category is content servers. Let's go ahead and look at some implementations of those 3 categories in typical applications. So here's kind of an abbreviated educational application. In the upper left-hand corner, you're looking at what you might have in a room like this, in a lecture hall. You might, in a higher-end campus, you might have something like this in several classrooms, where it's taking different sources, document camera, a camera on the instructor, computer graphics, there might be a smart board or other device, and it's basically ingesting those all, encoding them into a format, and maybe multiple formats depending on what the user needs, and then going ahead and pushing that up to a content server that might be in the cloud and used by a university system, for instance, in order to share content across all of its campuses. At the same time, locally, you can see at the bottom, classrooms would have set-top boxes, decoders with user interfaces that would be able to pull the content locally off the recording devices, or they could go ahead and pull it off the cloud. But more often than not, if somebody's pulling something off the cloud, they're going to do it with their portable devices like laptops, PCs, or smartphones. But here you see all 3 elements of those in here. Here's another application, and we talked about this one a little bit. This is a typical IPTV network where you have decoders at all of the displays that can tune a channel, but they're essentially just looking at an IP address, and off-air television programming is inputted into blades at the head end, plus whatever content that user might have. They might have some messaging boards and things like that that they broadcast on dedicated channels for their business or their educational institution. Okay, I want to focus the next part of this on managing workflow, because this is really the biggest challenge that we're facing today with streaming media within the enterprise. The key barriers to adoption of streaming media really have to do with this workflow, and they break down into 3 areas. Number 1 is training. Like anything else, somebody has to operate all this stuff, and generally the very users who are using it aren't the guys who are doing it. They need support staff to do it because it's technical equipment, and this is part of the workflow and part of the challenge. If I'm a professor in a university and I'm not off chalk yet, right? I haven't adopted the dry erase marker, then I'm probably not going to get in here and be typing metadata into a terminal anytime soon. So you have to rely on support staff. And there's a breakdown, by the way, in that, which I'll talk about in a minute, as far as how the content is managed when it's being supported by somebody other than the user. Security is another big one. In fact, when we first instituted recording all of our meetings in my company, and I showed you what that looks like, I found that I had to stop often at the end of the meeting and say, delete that. Because we might have talked about some HR issue or some confidential issue for the executive team, that couldn't be disseminated amongst the entire staff of the company. It would be a liability with HR. It's supposed to be private stuff, for instance. And the problem is, if you're relying on IT staff or you're relying on any technical support people to manage the workflow, then they have access to that content. Now, we're finding in fields that are adopting this in education, in telemedicine, in business, and in government, defense in particular, this is becoming a bigger and bigger problem. In fact, one of the biggest problems in medical, the telemedicine area exploded with streaming a few years ago and then got pushed back, both here and in the US, because of what they call in the US HIPAA regulations, which are basically, you have similar regulations here, I'm sure, but those are basically patient-doctor privacy laws. So you've got a school of psychology, for instance, on the campus of a major university. The students are the doctors, but the patients are real. In fact, most of the top medical facilities in the US are on university campuses. So in this situation, it's actually illegal by government regulation for anybody to have access to that content except the doctor and patient. But again, like the professor with the chalk, the doctor isn't going to be out there setting up bit rates and encoding parameters and all that in order to utilize the technology. So this creates a real barrier to market. And lastly is content management. Again, I talked about the fact that if you have to have support, it creates a problem for content management. We're talking really about metadata here. Now, metadata, again, is the data. It's put into that container as an XML header in a piece of content. And it has the name, the description, the author, the time and date it was recorded, keywords for searching it in a database, comments, any other information that you might want to put in there. And typically, that content is basically created by somebody who doesn't know how to create it because they're a technical person who is supporting the use. If somebody's writing about what we talked about in our executive meeting and he's an IT guy that wasn't in the executive meeting, he's not going to know how to write about it. If there's an IT guy writing about a physics course that somebody is lecturing on, they're not going to know how to write the right metadata, but that's what's happening out there. And that's one of the challenges that we have in managing workflow. So we'll take lecture capturing here because this is actually the #1 usage of enterprise streaming today. Let's look at the workflow. So the equipment gets configured, a profile created for recording is set up typically by IT support staff for that lecture. The recording either starts at a preset time or, technically the professor could probably start and stop the thing if he's not doing anything else. But it's often controlled by a remote computer or scheduled, and some systems require you to capture each slide during a presentation as well. After it's stopped, manually or by a remote computer, several processes have to take place, again, generally requiring IT staff to transcode. Transcoding is creating those other file formats. So if I want 720p on my laptop of my meetings and I also want it here on my iPad, I need 2 different formats. They're both MPEG-4, but they're 2 different resolutions. Somebody might need a Windows Media version as well. So you transcode the content for all the different users that might be utilizing that content. After it's transcoded and you've created a few different versions of it, you need to upload it to a server, delete it on the local recording device, because you're not going to store everything you record, and then enter all the relevant metadata, distribute it to shared digital libraries, for instance, in a university system, and then publish it to web pages. So for instance, there would be a web page for Dr. Weston's spring semester Physics 250 class that's going to have that content while the students are in that class, and it's going to disappear after that. Not go away, simply not be published to a web page. So that's the typical workflow in today's most common usage for this type of technology. Let's just look at it. I'm going to use what the interface for our equipment looks like just because it's convenient, but this could be anybody's equipment. Let's look at what that workflow really looks like for the user who's operating the systems. They need to log on to a media recorder, and then they need to create a profile. That's where you set up what's my color depth, what's my resolution, what type of file format do I want, what inputs, all of the things that tell it how to actually encode and record the content. You start the recording. After starting the recording, you stop it, obviously, and then you have to go back to that device, locate the recorded content, move it to a proper folder, and here we have Dr. Weston Spring Semester Physics 250 folder, so that's where you'd want to put that. Rename the recorded file so it's unique, transcode it into those different formats, and after that's completed, you'd enter all the metadata associated with that content. Now, a lot of times, like we showed in the chart, you're going to keep some of that content local. You need to do that both locally and you need to do it on a content management system. So this is somewhat of a daunting task that needs to often be done more than once. Those files are uploaded to a content server, again, typically manually. You log onto the content server, select the digital library, select the proper recording, sometimes, again, having to re-enter appropriate metadata for content management and publishing, and then it's cataloged on the server, distribute it to shared users, and from there, you're basically taking it and publishing it. This is an interface that shows that you've published it to different web pages, one in particular, and there's the web page where the content exists, and you can pull up any particular piece of content. So, no problem, right? As soon as we get Professor Weston to start using a dry erase marker, this is going to be a snap for him. Or this is going to be relegated to IT staff that in shrinking budgets they don't have. Or it's going to be operated somewhat incompetently by people who are not qualified simply because it's not their job to understand the nature of the content that's being created. Anyway, these are the challenges. So, in fact, Dan Rayburn, about 2 years ago, who's the EVP of Streaming Media, and this is a quote, he said the workflow for IP video is going to be the biggest problem the industry as a whole faces 24 months from now, and that's where we are right now. And as you can see by looking at this chart, you know, you've basically got maybe the user can start and stop the recording, but all of the other processes require support staff that are technically adept at using that equipment. So where is this going? The key to breaking down those barriers, and I'm talking training, security, and content management, is going to be in the automation of these processes. It's something that we at our company are focusing a lot of energy on, and it's really the thing that will allow, by breaking down those barriers, rapid adoption of the technology in the market. So I'll just show you quickly an example of what that looks like with one of the methods that we've created. Now, there are going to be a variety of different methods on the market, but this is something that we've created to solve that problem. We basically have created a key card, and that key card essentially sets up and configures the equipment, starts and stops the recording, processes the content, distributes it, does everything we just looked at in the workflow. The key is that the key card is associated with one of three things, or any combination of them. An individual, now that could be a manager in a business, manager of a division, it could be a professor in a university, it could be a doctor in a hospital. A user group, so with my executive team, for instance, when I'm recording something using a profile, the user group is my executive team, but I'm the individual. You know, but like for instance, with the example, Dr. Weston's Physics 250 class, for that, the student body of that class and whatever other faculty would be in that user group, which might be other people in other universities that are teaching similar courses, as well as the people enrolled at the local class. Work groups who are managing projects together, you know, all of these are examples of user groups. But also what's key to workflow automation is identifying the application itself. So I actually carry one of these cards that I use for those executive meetings that I showed you. And the card that I have says, it's my card for my weekly executive meetings for my executive team. It's identifying all three of those areas. With that, there are instructions on the card, which basically, very little instructions, so you'd be surprised, but they identify the profile, the distribution methodology, and all of the metadata associated with myself, my group, and that event. And By using that, it basically automates that process and eliminates support from the process, which also, of course, speaks to the security issues. So if we look at that same example with Dr. Weston's class, he would walk up to a podium like this and simply insert that device. And again, this is just one solution, first, on the market, but there will be several solutions. This could be an RFID tag, it could be a biometric scanner, it could be a barcode, it could be a variety of different types of user ID tags that can carry that data. And typically it would be remote from a recording device. So the lectern might have a little plate you plug it into or swipe a card, right? So you insert that on the lectern, and then all of those processes will happen automatically. When you remove it, when Dr. Weston is done, he pulls it out, and it basically processes all of the workflow from transcoding copies to uploading them to cataloging them, including putting all of the metadata on the file that's associated with that course and lectures on that course. More importantly, workflow automation is so important to the future of streaming media, and one of the reasons is because we're not only having problems with adoption within those verticals that use it today, like business, for instance. You don't see business using streaming media enough, but also markets where there isn't what? Support staff, where there's no IT staff. If there isn't IT staff to run it, they're not able to utilize it. And there's lots of applications in entertainment, worship, all kinds of different vertical markets that simply can't use the technology today because they don't have the support staff to operate it. So what I'm going to do here is I'm going to play you an excerpt of a promotional video, but it's not for that purpose. I simply want you to look at a completely different workflow than you've thought of in relation to streaming media that allows us to break down the barrier to a market that could otherwise never utilize this technology. And I'll give you a little background on it first. One of the largest cruise lines in the world had some of our products, and I was in a sales meeting and I heard they've got it in sea trials. And I'm thinking, sea trials? Or they get Jacques Cousteau out there? I mean, what are you going to do with a digital media recorder on a cruise ship at sea? So I got the feedback back, and apparently karaoke was a big part of what they do on these cruise ships. They wanted the ability to record people doing karaoke and basically sell them a DVD on the spot of all the songs they did that night. Just another way to, make money on the ship. It sounded like a great idea, but again, once we sat down and talked the customer through the workflow, they realized they would have to actually have an engineer manning equipment at a workstation that's saying, okay, Susie sung then in that file was put all those in a directory, then let's go ahead and author them all to a DVD. It's a pretty involved process, right? So what we did is we went ahead and very cleverly took the same technology and called it an artist keycard system. And again, I'll show you a quick 30-second example. This is edited from a promotional video, but it just shows the workflow. Whoop. Hang on a second, I've got audio. Do you have my computer audio? Oh, I did turn it that far down. Sorry about that. Here we are. Okay, sorry about the delay. This should work now.
The MediaPoint Artist Keycard system allows you to record every performance. You simply plug an artist keycard into your performer before starting each recording, then remove it and write the customer's name on the keycard with a dry erase marker. You simply insert your customer's keycards each time they sing all night long. When your customer is finished for the night, you insert their keycard again along with a blank disc, and your performer will burn a single DVD of all their performances. The MediaPoint performer saves each song as a separate track, including digital copies that can be uploaded to YouTube, Facebook, or their personal electronics. The write it on the key card. There's even a space to write down the table number or server's name. You can add a charge for the amount of songs on a DVD to a customer's bar tab right off the card. Then, wipe the card off with a soft cloth, reset the card, and it's ready to be used for the next customer.
So you see, in that case, we took the same methodology of a user ID. Those user IDs were associated with customers, and that was able to automate the process of tracking each and every performance by those, organize them, author them onto a DVD, and then go ahead and even handle a billing system associated with it, which was really just printing, the tag as far as how it was the workflow for the user. So that gives you an example. So we got to wrap up here real quickly. I just want to give you, kind of a future outlook of where we feel streaming media is going. We're terrible as a race at looking into the future. I was just on the plane on the way out here, and I was watching Alien. You all remember the movie Alien. Now, this is way off in the future, and yet all of the computers were green screen ASCII CRTs. Right? They showed video conferencing on a video phone at one point. It was about 100 DPI resolution, terrible image, and it was on a CRT monochrome. I mean, I can do better than that with my iPad. Where the technology is going, believe it or not, is we're going to get to a point where we can do instant recall, like Captain Kirk did in the Enterprise, where he says, "Computer, show me the bridge on this star date and what happened," wherever you are that you need to do that. And it doesn't sound believable, but that's because of our inability to look into the future, typically with technology. In the last 2 years, IP cameras have gone from being virtually unknown to being in every intersection, in every store you're in, just about everywhere you are, you're being surveilled by IP cameras. It hasn't been integrated yet on the cloud into something that we can easily go back and recall, but it will. That's just software. So there will be a point where every important place that you're in your life, you're going to be able to recall content, and that will change the way that we learn, it will change the way that we work, and it will, again, make a huge difference in the way that we advance at a race, because we'll have the ability to have instant recall. History will start being written that way. Anyway, that's all I have for you. Anybody have any quick questions? Okay, thank you all for your time. I appreciate it.